So yes, yes. So again, welcome all once again. So the lecture topic today is an extremely important topic for the current interdisciplinary development of faculty and students. And we have the best speaker who is an authority in this subject. So without much ado, I request Padma Shri Professor Sankar Pal to begin the lecture series part 1. And I think after 1 hour, there will be a break for 10 minutes. So I request Professor Pal if he can announce when he would like to break the session. So over to you, sir.
Thank you. Thank you.
Sir, 1 minute. I'd also like to announce that at the end we will have the question and answer session, and the participants can put up their questions in the chat box and we can for discussion. Okay, yes. Thank you, sir. You may start.
Okay. Good afternoon. Again, let me express my thanks to this organizing team for this AICTE DCP lecture series. The topic as I've chosen is highly interdisciplinary. You have to understand, we will explain machine intelligence, soft computing, granular mining, that means data mining, data science, and models, applications and challenges, and its evolution over the last about 50 years. Because I joined my institute on 1st of March 1975 to start working in pattern recognition. That time there was no book, no journal, nothing. At that time, no question of subject image processing or AI. So I will explain those evolution also. What's happened? So now the way I have prepared is follows. Explain what is soft computing with an example and its different components related to what we are talking about today, machine intelligence, artificial intelligence. And we'll explain the basic task of pattern recognition. That means this is the mother area and its relation with machine intelligence and soft computing. Then why soft computing tools required for this area? Then definition of data mining from pattern recognition point of view. Data mining has 3 kinds of definition. One from statistical point of view, one is DBMS point of view, but I will go via pattern point of view. Then different soft computing tools like fuzzy set theory, artificial neural network, genetic algorithms. Fuzzy sets is responsible for uncertainty handling and reasoning. Artificial neural network is responsible for learning, adaptation. Curve fitting, genetic algorithm is responsible for searching, optimization. So as you can see, all those characteristics are required in order to build an intelligent system. So I will explain them one by one and why this fuzzy set is required for pattern recognition, why ANN-GAs are required for pattern recognition, and then similarly a new subject area is called rough set, which originated from Poland by Professor Pawlak, then how it is relevant to granular computation and uncertainty modeling. You can keep in mind that whether the data is small or medium or large, certain uncertainties arising from overlapping is inevitable. And then I will explain the concept of granular computing, which we have been dealing with for the past decade. It's a new area we are developing, and application of different kinds of integrations. Then judicious integration of all those tools, different hybrid system, neural fuzzy rough neural fuzzy computing, what are their merits and demerits, why are they required. Then I will give more emphasis on rough fuzzy computing because both are uncertainty modeling paradigms. So how to make judicious integration. I'm not considering probabilistic uncertainty, that is uncertainty arising from randomness in occurrence of an event or probability of occurrence in an event. Even if you can bring that into together, then it will be much more stronger paradigm. And then how the concept of soft computing emerges, the different applications, then generalized rough set. This is a strongly very useful uncertainty modeling paradigm by integrating rough set and fuzzy set. Then application I will consider depending on the time, more elaboration to video analytics. So for this we need image segmentation, object extraction, different kinds of generalization and entropy measures I will be explaining. Then granular flow graph, all these new concepts, and the different kinds of granules, spatial color granules, spatial temporal granules, and so on. Then new concept of rough filter, entropy. The purpose is to track occlusion and overlapping. That means ambiguous situations. How to handle different ambiguous situations. Then if time permits, I'll go by application in bioinformatics, let's see. And maybe some application in social networks also. But this portion is more important at the end. What are the challenging issues? And when you do some research, you have to keep at least 5 to 7 years in mind that where are they going to lead you. So here in this context, I will mention the relevance to computational theory of perception, and under these G numbers, machine mind development, then relevance to natural computing and big data analytics. And when we talk about big data analytics, today deep learning is must. So I will explain the concept of deep learning and our new concept of granulated deep learning. And then I will explain different new architectures and their video tracking with several merits. And at last, I will explain the entire evolution of the subject from pattern recognition to data science with some caution, with some precautionary measure, because based on my experience, I can see that every time after 10 years, there is a buzzword thrown by America. Now AI is a buzzword, deep learning is a buzzword. So once it is a buzzword, uh, and if you want to start research, don't jump on this subject. You have to know the background first. So in this context, I will give some caution and conclude. So this is my entire 3-day program. So what is soft computing? As explained by Lasli Zade, he has passed away 3 years back at the age of 96. Now you can see in Google his name has come. So its objective is to exploit the tolerance for imprecision. You please read it very carefully. Imprecision, uncertainty, approximate reasoning, and partial truth in order to achieve these 4 characteristics: tractability of a system, robustness in a system, low solution cost, and close resemblance with human-like decision making. Suppose we are given to a parallel parking. You know, if you drive in a metro city, you have to make parallel parking. You cannot park the park longitudinally. So parallel parking means you put your car exactly between 2 cars. Now, if you know driving, it will take a few minutes just to park your car. The reason why? Because you are not asked to put the car exactly between 2, leaving 6 inches from the footpath, though it is required. But you are asked to put your car in between so that you don't hit anyone and also live very close to the footpath or car. But if I ask you to solve this problem very precisely, that means you have to keep exactly 6 inches from the footpath and exactly between 2 cars, then it will take hours of maneuvering. So the next question comes whether we need that kind of precision. Answer is no. And because the precision is sometimes meaningless and it is expensive. And this is what is the basically crux of soft computing. That means to find an approximate solution to an imprecisely or precisely formulated problem. Now, as I mentioned, the parking of the one matching. So high precision carries high cost, and sometimes it is meaningless also. And in most of our day-to-day problem in data mining, we do not need excess precision, and it is meaningless. So if you ask to solve the problem precisely, then it becomes very expensive one, because the distance, angular position to solve the problem. So therefore, the challenge is to exploit the tolerance for imprecision by devising some methods of computation which would lead to an acceptable solution at low cost. This is in essence the guiding principle of soft computing. And then it is a collection of methodologies which work synergistically, not that means they do not fight with each other, but they do help each other. Because why they help? Because every tools has some limitation. So other tools can cover up those limitations, and which is in one form or another reflect the guiding principle as I mentioned before, exploit the tolerance for imprecision, uncertainty, approach reasoning, partial to achieve that humiliate each other. So it provides the foundation for the conception and design of high machine IQ system. Therefore, it may be argued that it is soft computing rather than hard computing that should be viewed as the foundation for artificial intelligence system. And it also provides flexible information processing capability. That's become very useful for our pattern recognition, image processing problem. We need something which is flexible. This is not too hard. And this is the kernel of real world computing. At this juncture, the principal constituents of the soft computing are fuzzy logic, neural computing, genetic algorithm, and rough set. Rough set came later on, much later on. In original definition, these were not there. This is a contribution mostly from my group over the last 2 decades. So within soft computing, all these tools are complementary rather than competitive. You please keep this in mind. They do not fight with each other, rather competitive. Roles of the what are the roles? Fuzzy logic, it provides algorithms for dealing with imprecision and uncertainty in any kind of decision-making problem. Neural network, it provides machinery for learning and curve fitting. Genetic algorithm, it provides algorithms for search and optimization. And rough set theory, I will explain later on much detail. It provides algorithms for handling uncertainty arising from granularity in the domain. So there is a difference between these two. Here, the algorithm, the overlapping comes from the uncertainty comes from the overlapping of the idea, overlapping of class, overlapping of concept, overlapping of regions, etc. But here, uncertainty arises from the granularity in the domain. What is granularity? Suppose in an image, I can see that equal regions of the similar color, I can call it a granule. Regions of similar shape, I can call it granule. Even every pixel can be considered as a granule. I will explain you later on. So whenever the uncertainty arising because of the granularity in the domain, offset is very appropriate. So there is a difference between the two. And within soft computing, as I mentioned, I'm repeating, it's a complementary rather than competitive. Let me tell you in my throughout lecture for 3 days, some of the slides will be repeated just to keep continuity and also remind you about the basic features. Now,
Sir, sorry to interrupt you, but can you make the box which is there on the screen? The box which is there on the screen, no, on the right hand side, can you minimize it?
The box in the right hand side, yeah, it is just minimized already.
Because it is.
I think you can cross it. Yes, yes.
Now it's okay.
Yes.
Now it's okay, sir.
Okay, fine. I don't know actually why did it appear. It's a small box. So anyway, so this is the one. So as I mentioned to you, some of the slides I'll be repeating a few times just to keep continuity and to just remind you or to refresh you what are the about the basic feature. So after soft computing, then machine intelligence was defined in 1993 in our institute. We defined. So what is machine intelligence? It's basically core concept of grouping the various advanced technologies with the basic concept of pattern recognition and learning. This is the mother subject. So with this, when you group very advanced tools, and this list is not exhaustive because at that time it was fuzzy logic, rough set, probabilistic reasoning, because without reasoning you cannot have an intelligent. It could be probabilistic reasoning, it could be approximate reasoning, it could be case-based reasoning. Then different kinds of hybrid system, neural fuzzy genetic, data-driven system, nonlinear dynamics. Again, the list is not exhaustive. So when they all advanced topics interact with the basic concept of pattern learning to have an intelligent system, we call it machine intelligence, and the intelligent autonomous systems are nothing but physical embodiment of machine intelligence. So these are all linked. Now I'll explain what is pattern recognition and learning from basics. Many of the, I'm sure the audience, many people will be knowing, but then some people may not be knowing also. So what is pattern recognition system? It's basically three blocks: measurement space, feature space, decision space. So you take any object, you perform certain measurement of this object. This measurement could be numerical, measurement could be non-numerical. Numerical means you measure in terms of height, kilogram, and so other using parameters. That means sensor, using some sensor. Non-numeric means suppose it is a linguistic term. When you go to a medical doctor, you explain your symptom in terms of linguistic term. When you look at a scene, you can handwritten character, you can describe it by vertical line, horizontal line, circle, ellipse, and so on. So this measurement could be numerical, measurement could be non-numerical. Now, after having this measurement space, you'll see that all the measurements may not be equally important to make a decision. That means some measures are redundant, some measurements are ambiguous. Just like any kind of decision making, say for your faculty selection, if your experts are not chosen correctly, then the decision may be wrong. So any kind of decision making, based on which you are making decision, they should be nicely identified, appropriate. So here comes the question of feature selection. That means you reduce or discard some of the measurements which you obtain without knowing. So as a result, you reduce the dimension and also you reduce the computation time, provided you do not lose the information regarding the class separability, regarding the data, important feature, important concept, or important attributes. And then based on this feature, you make a decision. That means which pattern will go to which class, or for example, in an image, whether it is an image is a region of X or region of Y and so on. So this is in a nutshell, it's a three block system. It is from transformation from measurement space to feature space to decision space. Now, if you look at this, uncertainty can arise any of the situation from deficiency of information. Deficiency information means it may result from incomplete information, imprecise information, ill-defined information, not fully reliable, vague information, quantitative information, various stages. So once you have deficiencies, you create uncertainty. And then if they propagate, you get it exaggerated. So you cannot remove uncertainty, but you can reduce uncertainty. You can manage the uncertainty. That's why managing uncertainty has been a research area for several decades, because there are certain things we cannot avoid, given the measurement space. If you have another set of high power measurement, then could be sum of part will be reduced. So our challenge is, given this measurement, given this sensor, one, whatever I get, how to reduce the uncertainty. Now, suppose my input is an image, because when the subject was developed, that image was not developed because very expensive. So we don't have scanner or digitizer. So when the input is an image, I can see that I need some kind of pre-processing like enhancement, restoration, segmentation, thinning, edge detection, and so on. And therefore, that's why the measurement space can be called is a image processing space, because your ultimate object is to make a decision about the content of the image. But since it is a gray image, particularly if it is a gray image, where you cannot discriminate the object and just boundary or between two regions, because it is a sinusoidal variation of the image. Therefore, this you need to make some certain task which constitute what is called image processing. The input image, output is also image processing. But your ultimate objective is to make a decision. So then I can call it a image processing, and this is called low level vision and maybe high level vision. These are the terms you will be seeing in the literature with an amount of overlapping. So I can design or I can define image processing as a part of measure of the pattern recognition, where my input is an image, it's a matrix. Now look at the example of this measurement space. I'm just going to the one. I explained to you that measurement space, then you reduce the dimension from feature space. Suppose I'm just classifying two communities, Bengali and Punjabi. Just as an example, don't mind if there are some Punjabis or Bengalis or just as an example. So I can take certain measurements like height, weight, complexion, diet, with many things. I go to Punjab, I collect their one. I go to Bengal, I collect it, etc. Then I can see that all those measurements may not be required in order to identify these two communities or discriminate two communities. On the other hand, if I see only height and weight, if I take Bengalis most of the time, it's a less height, less weight, Punjabis over. But you can argue, you know, there are many Punjabis similar. Yes, I'm not going into argument. Let's consider an ideal situation, most probably. So this is a community where you have less height, less weight. This is a community more, right? Community. So this is called feature space. That means I can see that if I even do not consider other, just by two, I can have well separated between the class, and within class they are homogeneous. So this is called feature space. Then I make a straight line, y equal to mx plus c, our school level algebra. I call it a straight line. And this is what is called a classifier design. Now, I go to Bengal or Punjab, I have collected this information. So I call it a level data from Punjab. That way I knew they are from Punjab. I knew these are from Bengal. So I call it a training data, because I knew their source. I knew their class level. Now, given this boundary, I throw away all information. I have only this y equal to mx plus c, where I have known m and c. Now I collect an observation either from Bengal or Punjab, but don't collect from Odisha or Tamil Nadu, because this is designed for only for these two communities. So any person you identify from Bengal or Punjab, and you height 08 and 1, and you see this vector lies on the upper side of the straight line or on the below. If it is on the upper side, I call it a Punjabi. Otherwise, if it is below, I call it a Bengali. If it lies on the straight line, I call it indeterminate. That way, I cannot make a decision with the help of these two features. So that time we make the decision with with tossing a coin, head or tail. So this is what is called classifier design. And this is called training set, about which I have known there is a label set, that I know the data and their origin. And when I test it, I call it test data set because I do not know their origin, though I have used those information while finding the accuracy of this classifier. So this is a basic concept of classifier. But here you can see there is a straight line. But in real life problem, life is not that easy. So real life problem, what do you get? This is a very simple case, two-class problem. Here it is a not so simple because one is a smaller class, one is a bigger class. So if it is a smaller class, bigger class, and if you draw a straight line boundary, then you commit error. So it will be hyperspherical. That you allow more space for the samples coming from this region to get correctly identified as compared to this. Similarly, if you have this class of two classes, you get piecewise linear boundary in order to generate nonlinear boundaries. If you have this one class and one class, you get this. If you have this class, you get overlapping. You can use fuzzy boundaries, you can use neural network, you can use Bayes likelihood classifier. Here you can use KNN classifier. You can use neural network classifiers also. I will explain later on. Here it is a Bayes classifier if you use for unequal standard deviation. Different here it is a different mean but equal standard deviation. It is an unequal standard deviation. Here it will be hyperbolic classifier. So depending on this feature space, you have the boundaries linear to highly non-linear. That means you have to pay more money in order to segregate them correctly. So this is about the data feature space. Now, and the explanation that I gave before, it's called classification. That was given a few label samples. Now there is another case which is more practically that I have been given the entire sample space of the data, just like in remote sensing. National Remote Sensing Agency, Hyderabad said. They are using satellite to collect data of the Mother Earth. And you are receiving that data over the whole day and night. But you do not know which part of motherland is coming, and you do not know how many classes are there and which do they represent. You have no idea. But you are given the entire data set, and we give you task how to partition this data set into meaningful homogeneous region. Meaningful homogeneous region. Now, meaningful term is very much subjective. Therefore, you have different kinds of solution. Here it is called clustering problem. For example, in a family, you have 4 members, father, mother, son, daughter. This entire data set I have given you. Now I am asking you to partition them into meaningful homogeneous pocket. So what can be one solution? One solution is go by age, father, mother in one group, son and daughter in another group. If you go by sex-wise, father, son, one group, mother, daughter, one group. If you go by blood group-wise, then it could be son and mother in one group, father and daughter in one group. Now you can see that I have just only asked you how to segregate them or partition them into meaningful region. Now you have given me 3 different solutions because of the 3 different objective functions. So that means the problem is unsolved. Clustering means it is unsolved problem. But here entire data is given, as I mentioned you. So now if you see that, because why I'm telling, these are the 2 tasks mostly used for any kind of data mining AI problem. You have to understand this. So in one case, classification, what are the challenges here? You are given a sample data, incomplete information, and is given about the pattern space. That yes, these are the number of classes you have, so many classes, and also these are your some sample data about those classes. And the challenge is to estimate the unknown region of the pattern space based on this sample data. That means you have given only say 1000 sample from Bengal, 1000 sample from Punjab. Then you are asked to find the remaining people in Bengal and Punjab. So this is what is called abstraction plus generalization. Abstraction means you are abstracting from level sample some information, then you are using that abstracted information in order to generalize to unknown persons. So you please keep it in mind. The classification means abstraction of information and followed by generalization one. Whereas in case of clustering, you are given the entire data. The challenge is to partition it into meaningful regions, and here the number of regions may be known or may be unknown. Even if it is known, you do not have any label samples. Therefore, it becomes a very challenging area to find the homogeneous regions among all this entire data set, though the entire data set has been given to you. So here it is called supervised learning, and it is called unsupervised learning. And these are the notations I will be using very often. And any pattern machine learning, data science, you will be getting this term always. So this is the basic concept of learning came in 1960s. That supervised learning, that you have some labeled information before about the data space based on which you have abstracted, and then you are using this abstracted information to generalize, to recognize unknown. And in here it's called unsupervised, that you have no idea about the data set. Oh, even the just number of samples, number of regions, you do not have anything. Now, before I leave this portion, you have to keep in mind, most of the, in my opinion, more than 50% literature in pattern recognition research is related to clustering. Because it is an unsolved problem, that's why still you can write nice articles on this. Though there are certain validity index, cluster validity index, but basically it's an unsupervised. And if you know the cluster source, then the problem becomes supervised. Therefore, unsupervised problem is a challenging area, it's unsolved. And more importantly, it acts like a basic module in decision making and machine learning problems, particularly for mining large data set. Now, when we started working in 1975, it was a subject for electronics engineers. That time, computer science was not there. But then computer scientists, statisticians, they came and joined. So it became a subject of computer science, electrical engineering, IT, statistics. But today, no, it is a subject for anyone who is dealing with applied data. Any applied scientist dealing with data. So because why particularly for large data sets? Why say suppose you are getting bioinformatics and web data in 2000. So it's a huge amount of data, huge amount. Now, what is the problem? You are given a large dimension of data, and you are asked to find some relation within the data, find some pocket within the data, or anything. So, what do you do? You just assume certain number of class, C equal to 2, C equal to 3, 4, and you try to partition into those homogeneous one, and then see which homogeneous pocket is more acceptable. So once you get the homogeneous pocket, then from there you can start working. You can mine the relation, you can find the pattern of this the data set, you can find the centroid of those clusters, and then consider, yes, these are my number of communities or the number of regions there, and these are the centroid point, and that time you can reduce the dimension of the feature space to show those only the number of centroids. So what I mean to say, the clustering, though it was a subject of computer science EE, starting from EE, because all these subjects were developed by EE, that time computer science was not there. Statistician jumped afterwards, mathematicians, because it was developed because of the need. For example, that time it was a need to communicate with the machine in your own language. So patention came into picture. It was need required to find the crack in a bridge. So just how to find it. So you want to identify the crack using a machine, not manually. That's how patention came into market. Similarly, you wanted to communicate an image from London to New York through cable. So that's why the image processing came into market. Anyway, what I meant to say that clustering is a now must component, and it can be considered as a basic module for any kind of decision making, particularly when you are handling with big data sets. And that's why it has significance in bioinformatics web data. Now, before I go, you have to keep these two things in mind: training set and test set. This is for classification, supervised. Training set means you have known the origin of the data set. So you design your classifier or model, classification model or decision making model. Then you validate the model with the help of test data. Here also you know the number of their origin, but you do not use that information. So you plus use them as the attribute value, feature value as an unknown, and then check at what percentage your model or the classifier is able to classify this remaining data. That's called training data. So what you do, you collect a design set. Then you split into two parts: training set, test set. So use the train set to build your model and your test set to test the model. And obviously, it will be wiser that you don't use training set equal to test set. Then it will not be fair. So use training set which size is less, use test set which size is more. So that's why you will see in the literature, when you have design set, you have training set 10%, 90% test set, training set 20%, 80%, and so on, so on, so on. Sometimes you use leave one out method. That is, out of 100%, you use n minus 1 as 10 and just run it on the nth set. There are many ways. Keep these two concepts in mind because you will be using it always in case of supervised system. But sometimes in unsupervised system also, we make the case training set also, etc. Now, when you have an image as a pattern, as I mentioned to you, I use image classification based on pixel classification. I call it supervised. So in my following talk, these are the terminology you will use. And when I use image segmentation, that without knowing the class level, I just partition the image into meaningful homogeneous pockets. Then based on, say, for example, pixel clustering, I call it unsupervised. So image classification means supervised because you are making classification of pixels based on some prior information. And image segmentation means unsupervised. That means you are making your segmentation, that is partitioning the image into meaningful region based on clustering of pixels. And this is unsupervised. So keep this tool in mind. Now, typical patention applications since we started working, it mostly was in defense and space, plus in research is to like say biological and medical science. You have medical diagnosis, ECG, EEG, all these are pattern, X-ray analysis, cancer detection, everyone. This I mentioned because we have worked in these particular areas for long. Law enforcement, say fingerprint, from fingerprint how to identify the culprit, from handwriting, photograph, skull identification. In industry, computer-aided design, computer-aided CAM, CAD-CAM, product testing, assembly, robot, automatic inspection, so on. In defense, from satellite image, you get target identification, guidance, control, and so on. Then natural resource study and estimation. That means from agriculture, forestry, that means how much forestry one country has, agricultural characteristic, geology, environment. Tremendous use. Then man-machine communication, as I mentioned, they wanted to make communication with the machine in our natural language, not in terms of machine language. So here comes the question of automatic speech recognition. That our object is that machine will understand that what we are just speaking to the machine and what we are asking machine to do in our natural language. Similarly, automatic speaker identification, script recognition, speech understanding, natural language processing. The space science, interpretation of satellite pictures, Mars rover control. When I was at NASA, Houston, that time we worked on this Mars rover control project. The domestic appliances, refrigerator, vacuum cleaner, there also you need sensor to see how much food is inside you. This is also, they also play with the help of this camera and vacuum cleaner also this. So then you have web intelligence by recently, online social network analysis, security issue, drug discovery issue, and so on. So there are so much application. These are a few only just I mentioned to have an idea. So it has tremendous application, that means tremendous job opportunity. Now, Patention, when we talk about patention and machine learning, we had certain axiom that number of samples should be much greater than the number of features. But today, it has topsy-turvy. Sometimes, say for example, in your bioinformatics, you have a few thousand genes, but few hundred samples, because you go to hospital only when you are sick and you give your blood and other samples. So usually the number of samples becoming very less as compared to number of features. So here comes the patention and machine learning principles when applied to very large in terms of both size and dimension feature, and heterogeneous. That means in my previous one I told only numerical data, but now we have got heterogeneous data. For example, when you go to a doctor writes in a prescription in text, write in character, sometimes draw, sketch of some liver, lungs, everything. Sometimes uses color and sometimes spelling mistake. So data has become heterogeneous. It's not only numerical one. Similarly, if you look at a newspaper, what you see? It's a color. You have got alphanumeric, numerals, alphabets. You have got different images of texture, color, and so on. So that means today what you see pattern, it does not corroborate what we have learned in the theory. There we assume the number of samples is much larger than number of features, and sample is a numerical value. And if it is a sample is a non-numerical character, then we go by syntactic. But today we have applied patention machine learning both to very large and heterogeneous data set. Large means both in size and dimension, because that's why it's called, we call it data mining. And data mining has no meaning unless you interpret the knowledge. And this together constitute knowledge discovery. That means it is a process of identifying valid, novel, potentially useful, and ultimately understandable patterns in data. And here comes the natural language processing. So you mine the pattern. This is only one part. That what are the relation, how many classes are there, what you have identified in the characters recognition. Then you interpret some knowledge in terms of understandable patterns. For example, when you go to a medical doctor, doctor doesn't explain you in terms of mathematics, okay? Doctor says, since you have this pressure, you are diagnosed with this. So this is called knowledge interpretation. So this is data mining plus knowledge interpretation. It gives knowledge discovery. That means it's a process of identifying valid, novel, potentially useful, and ultimately understandable patterns in data. Now look at the evolution. Before I go further, you keep it in mind, and again at the end of the day, end of my talk, I will again explain this to everyone. Now, because based on this, I will be now going forward. So patention literature started in middle 1960s. If you look at the Google search, if you see it. We started working 1975 first March, but in India it got started in late 60s, mainly in TIFR, in Institute of Science and ISIC, Calcutta. Now, patention, CBC. Now, 70s, image processing came. And I went to Imperial College, started working in 1979 in image processing. That time, all over the world, in developed world, only few places. One in Maryland College Park, we remember, and even at Imperial College, we did not have image processing facility. Though Nobel laureate Abdul Salam was working in physics, but that time he was not a Nobel laureate, but he was using cosmic images. Then in artificial intelligence and expert system came in 1980s. Why it came? Because patention has certain limitation. And what is the limitation? Because it makes decision only based on certain measurement. But in real life, human mind does not work that way. We do not make measurement and then make a decision. For example, when you go to a medical expert system or law interpreter, what do? You have certain knowledge in your mind, and then when a new pattern or new patient comes, he matches or she matches and find the one. So it's based on rule based. I will explain later on. So AI, so expert system became a buzzword. Now, as today, AI and deep learning has become a buzzword. That time AI expert system was a buzzword, and AI also, and machine learning. But AI machine learning could not survive because that time we do not have large data. That's why in my institute also we introduced a course. But after 3 to 4 years, no student opted because there is no job. And similarly, artificial neural network, that time it came. So it's 80s. Then it has certain limitation. So we use knowledge-based system. That means you collect the knowledge base and make one, and from the knowledge you generate new knowledge, just like human mind generate. Given this you infer and you generate new knowledge. And when you generate new knowledge, you extract certain amount of case-based reasoning and human-like decision, soft computing, information retrieval, all new terms occur. So every evolution evolves some new technology, new terms. Then in 2000, because of WWW and Genome Project, we got data mining, large data. Then in 2010, we called it big data. Why big? Because it is becoming a tsunami. Large volume, large velocity, large variety, large veracity. Large volume, it is coming because today you are getting all those digital, because of the digital revolution, data is generating in huge, abundant data. Today, when we started working, there was data scarcity. My patention problem, when we published paper, we had 871 data of speech and then 3 features. Today, it is other way. So big data means large data size, large velocity, that means the speed it is generating, large variety, that means it has got heterogeneity, and large veracity, that means conforming to the fact. And then we could not solve all this problem. Now we are talking about data size. So, and every evolution has generated new tools and technologies because of the data. And therefore, what you have developed in 80s, pattern recognition, you cannot use them right now. I will explain later on. Because that time, the clustering concept of a small data, and today, clustering concept of a heterogeneous data is completely different. So every time evolution has given you birth of new technologies and I will explain this one. So what was the expert system 85? To address limitation of pattern recognition. Medical expert system incorporates expert's opinion, law interpreter, doctor. So we made a probability theory in rule base. If A, then B. Just like doctors say, if your pressure, temperature are this, then do your this. If this, so in the form of a rule, if then we use probability theory, we use fuzzy logic, we use rough set. So there are fuzzy expert system, probability expert system, rough set theory. Lots of funding came in 85. That time I was at NASA, Johnson Press. I was listening because NASA, I do not know whether they know, it also funds for research to small scale industries, to university, to institutes, and support internship and other things. So I saw that it's become very important. Then, based on the Alan Turing, 1947, his realization that learning AI, machine learning, learning patterns for examples or sample data. It was completely based on Alan Turing 1947. And it was him who first said in his lecture in the Mathematical Society, London Mathematical Society, that we need a machine that can learn from the environment. Just one line. We need a machine that can learn from the environment. And that is today what you're talking about, machine learning, AI machine learning. So it was envisioned of intelligent machine was back in 1947. What we are talking about today, they are all we are unfortunate that he has passed away at the age of the 42. That probably is some of this breakthrough paper you can go by the Mind Journal. So AI and machine learning, it came around the same time. Machine learning means learning patterns from examples or sample data. This is one way of writing. But somehow, as I mentioned, lack of adequate data and pre-processing power, storage capacity. So that's why its subject could not survive. Then in the 90s, we got knowledge-based system. India had 5 KBCS knowledge center. One is TIFR, one is ISI, Calcutta, one is IIT Bombay, IIT Madras, one is Institute of Science, one is IIT Kanpur. So use domain knowledge, that is knowledge-based word originated, and reasoning to derive new knowledge to solve problems. This is one thing, and incorporate higher level knowledge, semantic, pragmatic, etc. in the rule base and in the interpretation to make the system more intelligent. And new terms like knowledge representation, case-based reasoning, that just like just like law interpreters, they make the decision depending on the cases. So it's not a uniform reasoning, it's a case-by-case reasoning. Then rule learning, adaptation, updation, information retrieval. These are all typical terms came first, because since you have a knowledge base, it is a next question is how to first retrieve it, because you have got so much information you have stored, and if you ask today and then the question query and you get the reply tomorrow, it has no meaning. So, and accordingly, that time emergence of soft cognitive technology, because it provides flexibility, tractability, just like human mind, low cost solution, and human like decision making. Now, our objective was to always to make the system more intelligent, starting from pattern recognition, expert system. We want to make the system make a decision like human being, like intelligent. That is the objective. So what are the characteristics? One, we can see that uncertainty handling, because any data has uncertainty, or any decision making involves uncertainty. It could be from vagueness, randomness, probabilistic, granularity, whatever. And we need to have the reasoning capability, just like human being. If A equal to B, if A then B, then what will happen if A star, then it should be B star. So how to find A star to B star, reasoning. The adaptivity and learning, that means how to be adaptive in new environment, just like our humans. Human is the most person to get adaptive with the new environment. Similarly, learning capability, searching, comprehension speed. So these are a few characteristics which characterize any intelligent system. We want to make it most increase the analytic capacity, reasoning capability, learning capability, searching capability, comprehension speed, and these are all boiled down to, again, machine intelligence. Now I will explain all these characteristics, how are they obtained using soft cognitive tools. That means fuzzy logic, neural network, genetic algorithm, and so on. So relevance of the tools to pattern recognition problems. So in one of the challenges pattern recognition, that how to handle overlapping classes. One man is going, another man is occluded, overlapping. Two classes are overlapping. That's the problem. I just showed you all kinds of feature space, how to handle those overlapping classes, regions, concepts, etc. There are two ways. You use probability theory, which needs probability distribution function. And we use another is fuzzy set theory, where you do not know the distribution function, where you do not have sufficiently large samples to find the distribution. So you can use membership. And if they do not follow any statistical distribution, so then you go by the non-parametric method called membership function. Now I will explain those things. Therefore, this is the fuzzy set theory I will explain. This is the first paper, 1965, which has got this many citation, 1,23,000 space paper. And when I started working, I joined my institute in March 1, 1975. This paper I collected from Calcutta University. My Indian Statistical Institute did not have any journal related to electrical sciences because it is a statistics and mathematics institute. Now we have got all journals, but that time we did not have. And this Professor Jade Berkeley, who first explained the theory of fuzzy set, passed away on September 6 at the age of 96 plus today. One. What is fuzzy set? Many of you might be knowing. Now I'm saying it's a classical set. What is classical set? That an element belongs to the set or does not belong. Suppose I say set of boys, then all boys have membership value or this characteristic value 1, and all girls have characteristic value 0. If you say set of integers from 10 to 20, then any integer from 10 to 20, they have value 1, otherwise before 1 to 9 or 21, they 0. So it's called hard set. Hard set. Yes or no, 0 or 1. Or yes, no, black, white, just like switch, off, on. Yes, no, that is, it's called hard. It's a hard decision making. That guy is very hard when he's working. When I think that yes, yes, nobody can make me no. But we need sometimes flexible guy. So here comes the example of say tall man. Here I cannot characterize by either tall or not, because any person is tall is a matter of degree. Any street is long is a matter of degree. Any number is large is a matter of degree. Any corner is sharp to a matter of degree. Any person is young, boys or young. Similarly, beautiful, large, blonde area. There are so many thousands of examples where we do not have crisp boundary like yes, no answer. Rather, soft. That means any man is a matter of degree to become tall. Definitely, who is 6 feet, will go 1. Who is 4 feet, will go by this. Similarly, any lady is beautiful, it's a matter of degree. So this is what is called fuzzy membership function. This is what is called fuzzy set. That means here the characteristic function lies between any value from 0 to 1. Here it is either 0 or 1. Here it is any value from 0 to 1. Obviously, extreme case 0 or 1 boils down to classical set. Otherwise, it is a soft decision. It is easy to climb, flexible. This is flexible. So this is what is called fuzzy set. This is classical set characteristic. Yes, no. Here it is a gradual change. So it is characterized by this way. It's a pair X and associated membership function to A, where A denotes an imprecise set. Suppose the tall man set is A. Any person has a membership value to become tall. So this membership value in between 0 and 1, say 0.6, and that person tall. So it is a pair for all values of X in the universe. This is the notation you can use, or sometimes you note a slice. So when mu A is equal to either 0 or 1, that means that element either belongs or not, it becomes a classical set. Otherwise, it is a membership function, lying values, taking any values from 0 to 1 inclusive. Now, membership function, it's a degree of belonging of an X element to A, or degree of possessing some imprecise property represented. This you keep in mind. A must be an imprecise property, imprecise person, imprecise set. It has nothing to do with precisely. So membership function means degree of belonging of element to an imprecise set A, or degree of possessing some imprecise property represented by A. Suppose when you say bright region has no value 0 or 1. It's a matter of degree in the pixel, in the image. So I can let us define a property called bright property. Let us call it a edginess property. Let us define a textural property. Then I treat it as a membership function. So membership function are nothing but, fuzzy sets are nothing but membership function. You just keep it in mind. In case of classical set, it is a set of values which belong to this set, which have value 1. But in fuzzy set, there is no question of 0, 1, any value from 0 to 1. So fuzzy sets are nothing but membership function. So this membership function means fuzzy set. In case of classical set, this is only this polymer of this amount of elements. After here, they belong to the classical set. So fuzzy sets are nothing but membership functions, and membership functions are context dependent. That's most important. I will explain why it is context dependent. That means the same person in India height 6, when you go to Germany or some other European country, say, I have seen their tall means about 6 feet 1. So the same tall definition in India, same tall definition in Hungary, for example, is completely different. I'll give you an example. Suppose you are asked to your friend, is young at the youngest age, what do you do? Suppose you are asked to meet your friend at 1 o'clock, or you have asked your friend to come to your house at just 5 o'clock. So mathematically, this 5 o'clock means here it is a characteristic value 1. That means before or after, its value is 0. So ideally, this is basically a crisp set, okay? But in practice, when you are asked to meet your friend at 5, or for example, you are expecting your friend to come to your house, what you see, or you are expected to attend a meeting, attend a class, or usually sometimes what do you do? 5 o'clock means it could be 5 to 5, 10 to 5, it could be 5 past 5, 10 past 5. So in reality, it becomes a fuzzy set. Though in ideally 5 o'clock means is crisp set, but in reality it becomes a fuzzy set. That means many people come before 5, some people come also after late. Now this membership function is dependent on context. For example, the train comes at 5 o'clock. If you go to Japan, even China, 5 o'clock means 5 o'clock. I was traveling from one part to, because Japan everybody knows, but even in China, from one city to another city, I was traveling to Chengdu, from a hill station, Chongqing. So we are surprised that train 5 o'clock is 5 o'clock. And some lady like from airport hostess, they came out to take the ticket. So here, but in my country, when it's a train comes at 5 o'clock in a just middle of the station, you do not know whether the train will come after half an hour or 1 hour or 2 hours. So that means the 5 o'clock defined in my country in the respect of train, or 5 o'clock defined in the respect of other country is different. So this comes up easily. Similarly, look at this some young boys and girls. When they find their boyfriend, girlfriend, what you do? Suppose they are supposed to meet at 5 at some point. So what do they do? Usually have seen they always try to come before 5, so that if the partner comes before 5, they can have more time to spend. So here 5 o'clock starts much before 5, but no way after 5. But when the relation gets little bit older, very often, or okay, sometimes, I've seen that the one party comes much after the 5 o'clock to make the other her or his friend angry. So their 5 o'clock goes by. That is the same 5 o'clock for between the two lovers, depending on the time, depending on the relation, the age of relationship, the is defined other way. So this is the beauty that, as I said, it is nothing but membership function, and membership function are context dependent. And this context dependent property, you can say, so for any kind of domain, you give a transformation, 0, 1, fuzzy sets are membership function. And therefore, fuzzy set is a generalization of classical set theory. Classical set theory was 0 or 1, but here you make it in any value between 0 and 1. So it has greater flexibility in capturing faithfully various aspects of imperfect completeness or imperfect in its situation. For example, this flexibility is associated with the concept of membership function. If membership function increases, means amount of stretching the concept to fit him or her, the imprecise concept decreases. For example, between two persons, or somebody's height is 6 feet, somebody's height is 5.5 feet. So for the fuzzy set tall, the person who is 6 feet, for his, we need the amount of stretching to fit that man or woman with the concept tall would be less as compared to the guy whose height is 5.5 feet. Therefore, as membership value increases, amount of stretching required to fit a person or fit some element with the emphasized concept decreases. And therefore, you can say fuzzy sets are elastic. That means you can stretch it. Hard sets are inelastic. And this property makes it very useful for pattern recognition and the decision-making problem. And now, before I leave, one may ask question, what is the difference between with probability and the membership function? There are so many examples. First of all, let me call it, the probability of an element X is concerned with the number of occurrence of an event X. For how many times it has occurred out of 100, then from that we compute Px. But membership has of element has nothing to do with this occurrence. It concerns only the competitive, the similarity of this element with the imprecise concept division to a mu. So this is a completely different thing. Here mu x means similarity or compatibility of an element with the imprecise concept as represented by mu. Whereas here it is concerned with the number of occurrences the element has occurred. So there are many such examples where probability of occurrence changes but membership value does not change. Because probability depends on the number of times. So the characteristics, flexibility and uncertainty analysis. This is one of the very strong requirement for any patention image processing or data mining problem. And it is coming from overlapping concept regions, etc. And obviously, this theory had impact on mathematics because mathematicians jumped to generalize the theory. Modeling and control, patention image processing were AI, data analysis, neural networks, the real world application like business and finance sectors, social and behavioral science because our human mind works based on this soft decision. Electronics, robotic system, cars, domestic appliances, etc. So if you have look at the literature, there are 3 types of application. In case of control-based system, you replace or emulate human operator. That is low, medium, high. It's just human operator, layman, he doesn't know. You ask him to, if this, you rotate the knob low, you rotate the knob at high, medium, just like our oven. Expert system, you replace the human expertise. be a medical doctor or interpreter. But here, our purpose is to generalize the uncertainty, generalization uncertainty. That means we do not make hard decision. We make the soft decision. Because once you make a hard decision means you have lost all information. But if you keep the information as much as possible, then at the end of the day, you can make it hard. So the challenging issue that time it was how to bring out the root relation between abstract concept of fuzzy set and the task of patention image processing. That time there was no book, nothing patention image processing. There was no book on abstract of this fuzzy set also. Just it was a concept. So we gave the concept of notion of multi-class belonging. That a pattern can belong to more than one class. Previously, we made a decision, assumption that a pattern has come from only one class. That means the guy is from Bengal, he cannot come from Punjab, or the guy from Punjab, he cannot do one. But now we say that no, depending on the feature, we can say that a pattern can have more than one class belonging. Similarly, it's an image, gray image. Look at the sinusoidal variation. So the grayscale image with sinusoidal variation of gray values. So here I cannot define the region exactly because if I put the boundary here, this is a questionable. If I put boundary here, this is a questionable. So this gives rise to the concept of ill-defined boundaries, ill-defined edges, ill-defined regions, corners, relations between regions, between their geometrical properties, all become fuzzy because of the gray. Therefore, this was the output by making a root relation between the two concepts. That a pattern can belong to one. Similarly, an image can have ill-defined boundaries, ill-defined region, fuzzy corner, fuzzy relation. It cannot be crisp. Therefore, multi-class membership of a picture element with any value to belong to this one of these relations or boundary region lies between 0 and 1, not 0 or 1. A pixel can belong to a boundary with this, not this. Pixel can boundary to an edge with this value, not this. Corner relation 1. So it's very nice. So accordingly, if you look at the relevance of fuzzy set theory, and just this was the first paper from our laboratory in Calcutta, 77, in speech recognition, and this is the first paper back in 1980s in image processing when I was working at Imperial College. Relevance of fuzzy set in pattern recognition. What has happened? Representing linguistically phrased input feature. That means I do not have any, for example, numerical input. When you go to a medical doctor, you usually tell my doctor, my pressure is high, pressure is what. So when she measures, then find this. So it's a linguistically phrased input features for processing. Then representing multi-class membership of ambiguous pattern. That is a pattern coming from straightforward region where we have no duty and also pattern coming from overlapping region. I call it ambiguous pattern because it can belong to one of these classes. Similarly, generating rules and inference in linguistic form, just like doctors generate rule and just suggest you have this because you are this. When you ask the doctor that why did you say I have this? Doctor say this measurement is this pathological measurement is your symptom is this is a measurement, that's why. So you generate rules and inference in linguistic form. And in case of image processing, as I mentioned, for extracting ill-defined image region, primitives, properties, this relation, you have fuzzy set. So these are the characteristics that made fuzzy set theory applicable to patternation image processing problem since their inception. For example, consider it's a patternation problem, 3-class problem, overlapping. So this is a 2 feature X and Y. These are my 3 pattern classes. I can see that this feature X ambiguity, it can belongs to this class with the membership value mu1, that the degree of belonging to this class, mu2, mu3. Now the next question you can say that what I will do with this three-dimensional vector? I need a concrete decision. Yes, what you can do? Initially you made a two-dimensional two decision, correct and wrong. Now I can have first choice, combined choice, second choice, wrong choice. But I declare wrong only when I'm sure about them. Otherwise I keep them fuzzy. First choice, no problem, I can go by this. Combined choice, both are correct, first and second. Second choice, first choice is not correct, but second choice. So proposed four states. So samples under combined choice, second choice can be corrected at higher level under control of a supervisory program. For example, if you see that in India, in several parts of the country, you see that many roads are surrounded by trees, roads nearby water body. So when you take a satellite image, say by 10 meter by 10 meter resolution or 20 meter by 10 resolution, so all these 10 meter by 10 meter or 20 meter, they represent not only the road, they can represent the nearby vegetation, water body, etc. So therefore, information on a pixel is not only from concrete, but also from vegetation or water body. Decision on a pixel should indicate its multi-class membership with certainty values. Similarly, in a bridge over a river, when you take a satellite picture, part of the pixel will represent a bridge that may concrete, some of the portion may represent the water body. So what to do? So in that case, you cannot make 0-1 decision. You have to go by the second choice, combined choice of all pixels, and then see you have a higher level knowledge what the linking of bridge can be guided with the second choice, because every bridge will be connected on the either side with a road. So I can see that if the road is connected, if the bridge pixel is connected or they have close resemblance with the road pixels, then I can make them correct. So with the help of higher level information under control of a supervisory program, I can use those combined choice, second choice, one. But if I would have thrown out all those things, making only two state, then I had no other option to get those information back. This is a typical one on Calcutta, is a spot French web satellite with infrared 20 meter by 20 meter resolution. This is a race course, Samkhedipur River Ganges, whoever knows about Calcutta. Now, if you look at this, let's consider these are the areas. Water, this kind of water, this is another kind of water. So let us call it water or the pond water. Then concrete, habitation, vegetation, open space, and something null. We do not know one. So there were 7 classes, 1, 2, 3, 4, 5, 6, 7 classes. And you see that the classified image I'm just showing you. Now this is my river, that famous Howrah Bridge, if you look at this. So it is merged with some water body plus concrete one. Now, if I take the concrete structure class, first choice, combined choice, and second choice, I can see that first choice concrete class, white. This is a null choice. Second choice comes here, and combined choice comes this one. So I can see that bridge, which is a concrete pixels, bridge is made by the steel concrete pixels, get confused mostly with pure water under combined choice. So if I know pixel wise they are second choice, I can recover the bridge by assigning those second combined pixel to road, because they are connected to either side by road. So this is an example I'm showing what is the significance of multi-class belonging, and this is true for our natural language processing also. Now note, before I leave this section, we have first paper in 1969 by Eric Luspini from Stanford Research Institute, new approach to clustering. What is the new approach? The clustering should be fuzzy, not crisp, and patterns may have origin from more than one class. Then Bezdek and Dunn, they have fuzzy isodata, fuzzy C-means, initiate a new direction to faster cluster analysis. Then our first paper came in 1975 for sets in speech recognition. Why speech? Because speech data leads to very ambiguous data because biological patterns are in manifest ambiguity. See, in the same word when you speak, in the morning, in the evening, it changes frequency. Same word when you utter you're angry and when you're in a lovely mood, they change one. Therefore, speech, any speech data which or is of data originated from biological origin, it manifests certain kind of ambiguity, which have nothing to do with the randomness, but is something to do with the vagueness. And similarly, the lady Judith Prewitt, 1970, first mentioned the image segmentation should be fuzzy subset of image. As I mentioned to you, segmentation means clustering. So it should be fuzzy subset. It cannot be crisp. And Rosenfeld and his group, University of Maryland, first paper in 79, extending digital geometry to fuzzy subset. And me and my thesis advisor, Bob King at Imperial College, the first paper in electronics later, that is a very prestigious journal that time, IEEE publication, Institute of Electrical and Electronics Engineer, 1980. Why fuzzy image processing? In a nutshell, a great one image processes ambiguity within pixels because of the possible multiple levels of brightness, and this indeterminacy, both in grayness and spatially. What is the grayness? Because that whether the pixel will be considered white or black. This is the ambiguity. And what is the spatial indeterminacy? That is, where is the boundary of the region? If I ask you the question, what is the boundary of the region? That incorporates spatial ambiguity, spatial indeterminacy. And when I say that whether the pixel value will be considered black or white, this incorporates grayness ambiguity due to inherent vagueness rather than randomness. And many concepts of image analysis, for example, concept, age, as I mentioned, they do not lend this to precise definition. So therefore it is convenient, natural, and appropriate to avoid ourselves committing to a specific hard decision by allowing the segments, skeletons, or contours to be fuzzy subsets of the image. They are this subset being characterized by the possibility or degree of which belongs to other. This is very basic question, and that gives light to entire fuzzy image processing literature since we started in 1979. And Rosenfeld group, as I mentioned, it was 1970. So that is the history. Rosenfeld group 1979 and we are 1980. So these are the uh, pioneering article all over the world that time. And therefore, let us conclude by saying notion of embedding. So we find a better solution to a crisp problem by looking in a large space at first, which has different, usually less constraints, and therefore allows the algorithm more freedom to avoid errors as forced by commission to hard answers. This is a lesson. So this is called notion of embedding. You find if you work in the fuzzy domain, you find a better solution to a crisp problem because you are looking in a larger space, just like real and complex. You are fuzzing, and which has different, usually less constraints because it is flexible, and therefore allows the algorithm or methodology more freedom to avoid errors as forced by commission to hard answers in indeterminate stage. With this one, I stop for my first portion. It's okay now? Let us take 10 minutes break.
Yes, sir.
Yes,
Yeah.
sir. Yes, sir.
Okay.
Yes. Thank you very much, sir. It was really an interesting session to net. I mean, a lot of basics, right from the what is classical set and fuzzy set. This was well explained by you. And I now request all the attendees to kindly remain logged in. We'll take a break for 10 minutes and join back on the session In case you log out from the meeting, you are supposed to join from the same link that was sent to you. But I suggest you please remain logged in this session. So thank you very
Vaishali,
much. Yes, yes.
Dr.
Okay, so
Vaishali,
now 10 minutes,
if
huh?
we can, if we can just have ask everybody to put their video on and take a photograph
Yes, yes, please. Yes.
before they
Yeah.
go for break.
Okay, okay. So I request all the attendees to switch on the cameras, please.
Madam, they will not be able to do by themselves.
Oh,
Uh,
I'll have
okay.
to change the settings first.
okay,
So
okay.
just give me a minute.
Yes, please.
Please don't leave. We'll just take a photograph. Sir, you can stop sharing so that we can have large gallery view.
It's okay.
Yeah, I have allowed now the camera for the attendees.
Yes, all attendees, please switch on the cameras, please.
Sir, you have to stop sharing, sir. Your screen is still seen. You see a cross, please click on that. Yes, yes. Now okay, now okay.
It doesn't seem like they are able to switch on the cameras.
I'm able to
They are
see.
switching.
Yeah, they're
They are
switching, no?
switching. I can see.
Ye-
Yes, yes,
Yes, yes, yes.
yes.
Okay.
If
So,
you go
Dr.
to
Shalata?
large gallery, you can see everybody, Dr.
Yeah,
Vaishali.
yeah, yeah.
Okay, just give me a minute.
Yes.
Gajanan, you can also take some photographs.
I would like to mention here that Colonel Venkat will be joining us after the break. He'll give his address and then Shankar sir will continue.
Okay.
So 4:50 we can join.
Okay, 4:50. Yeah. So all the attendees are requested to join at 4:50 p.m.
Or need not log out also.
Yes, yes.
Madam, should we stop the recording and resume again, or let it be in continuation?
Shalaka, can we stop recording?
Yes, madam. That is what I asked some time back.